Hello students, so welcome to part 7 of the lecture series on previous year GATE questions of electronics and communication on network theorem topic. We have already completed 6 part of the lecture, so if you have not gone through then please go through them, and let's begin with the part 7. This video lecture series is provided to you by the EDAMIGO team. So let's move on to the question directly. So this is the question. So we have to find Thevenin voltage and Thevenin equivalent resistance between terminal A and B. Okay. So I will be just copying the figure. Okay, now. Okay. So we have to find the Thevenin. First of all, we have to find the Thevenin voltage, or we have to find the open circuit voltage across the terminals A and B. Okay. Now let us assume that, so we have to find VTH, that is question mark. So let us assume that this is grounded and this terminal, now since B is grounded and A, the potential difference between A and B is VTH, so I can say that this terminal is at voltage VTH. Now simply applying the KCL at node A. So let us say that this node is capital A. Before that, we can see that I1 will be the current which is flowing in this branch. So that will be equals to VTH minus 10 divided by 5. Very simple. So VTH is the voltage here, 10 volt is the voltage source here. So since this is grounded, so this will be at 10 volt, and the voltage difference between the 5 ohm resistance will be VTH minus 10. So the current is VTH minus 10 divided by 5. Okay. So the incoming current is 1 ampere. So I am writing with minus 1. Outgoing current is VTH minus 10 divided by 5. Another outgoing current is in this branch, that is VTH divided by 5 is equal to 0. So VTH divided by 5 2 times, minus 1 minus 2 is equal to 0. So VTH is equal to 15 divided by 2, that is 7.5. Okay, ohms. Sorry, 7.5 volts. Now to find out the equivalent resistance, we can easily, first of all I will just draw the figure again. Okay. So to find out RTH, since we can see that this is independent source, this is also independent source, and this is the dependent source. So all the independent sources, that is 10 volt and 1 ampere, are removed from the circuit. So how are they removed? They are removed by open circuiting the current source and short circuiting the voltage source. So we open circuit the current source. So this was the current source, I open circuited, and here it was a voltage source, I short circuit that. Now by doing this, we can see that this dependent source is of no use now. So we can easily see that RAB is the parallel combination of 5 and 5 ohms, that is 2.5 ohms. So easily we can say that VTH is 7.5 and RTH is 2.5 ohms. So option B is the correct answer. So this is the next question. It's a very simple question. It is given that 10 voltage source, 100 ohm resistance and RL. Now since for maximum power transfer the value of RL should be 100 ohms, so P max will be I square into RL. Since current is 10 upon 200, so P max will be 10 upon 200 whole square into RL, that is 100. So that is 1 upon 20 into 1 upon 20 into 100, that is 0.25 watt is the maximum power. Okay, so this solves the question. Now this is another question, a very simple question. So it is given that there is a voltage source which is of 1 radian per second. The source impedance consists of a 1 ohm resistance in series with the inductance of 1 Henry. Now 1 Henry will have impedance of j omega L, and omega is also 1, L is also 1, so impedance is equals to j. Now the load that will obtain the maximum power transfer is, so we have to find the value of ZL for maximum power transfer. So we can say that the source impedance is 1 plus j. For maximum power transfer, ZL is equal to ZS conjugate, that is 1 minus j. So we have already seen this in the previous part. So if you have not gone through, then please go through that video. Okay, so ZL equals to 1 minus j. Now we can easily see that it is actually a series combination of a resistance of 1 ohm and capacitance of 1 farad, because the impedance in this case will be 1 plus 1 upon j, that is 1 minus j. So the answer will be C. Okay, so we will continue the lecture series in the next part. So thank you guys, stay tuned.